Hi folks, what we're going to look at today in this video is how you can use Excel to analyze the data that you found for your project and hopefully to solve some problems that may arise. All right, so first step is to find your data, which hopefully you have or you'll be looking for soon. And so what I did here is I found some data on land temperature, and you see here that it's organized into region, but there's also a summary that takes an average of all the land temperatures over many years, as you see from 1750, and that's what I'm going to look at. All right. Now in this case here, the data that's given is just as a table. Okay, so if you get lucky and find your data that can be downloaded as an Excel file, then you can skip this whole step and go to the next part. All right. So first thing is to understand what the data actually tells you. So it's a good idea to make sure you read, see what it tells you. So it tells us that temperatures here are in degrees Celsius. Okay, and if you notice here, you're seeing some negative numbers. You might think that that represents a negative temperature, but that's not what this represents. It says that they're reported as anomalies relative to the 1951 to 1980 average. So essentially what they do is they took an average for these years, and this number represents how much above or below that number the measurement is. All right. And if you look at the bottom here, it says that the estimated absolute temperature as an average over these years is 8.64 degrees Celsius. So that's our baseline. Okay. So I'm just going to write that down here, that our baseline temperature is 8.64 degrees Celsius. Okay, so these numbers here represents how much above or below 8.64 we're at. All right, and we see that we go from 1750 all to the present. Okay, before I move on, there is one thing I'd like to look at. Is this here gives you the annual uncertainty. Okay, if you read it, they tell you about the uncertainty. And just take a look at column 3 and see how that's a pretty big difference when we're talking about 8 degrees, a difference of possibly 1 degree. And as we move further down, we see that that uncertainty becomes smaller and smaller and smaller to the point where we're at more modern times. And look at how small the uncertainty is. So the expectation is that the more recent data should be much more accurate. All right, so once you've found your data and you understand what it means, we're going to take this and put it into Excel. Since I couldn't download this as an Excel file, I'm going to take it, copy. I'm going to do Control-C here to copy it, and now I'm going to go onto an Excel file, and I'm just going to paste it. Okay, so one of the problems that you might encounter is that what I've done is I've just copied and pasted this table into Excel. Okay, everything is in column A. What we need to do is separate this out into different columns. So if you have that issue, this is how you're going to do it. All right, so first thing you're going to do is you're going to go to data. Now, if your version of Excel is a little different, that's fine. Just go to data, and what you're looking for is text to columns. All right, you go to text to columns, and what it does is it gives you a way to take this table and turn it into individual columns. All right, now there's two ways you can do it. The one we're going to use, fixed width, as you see, fields are aligned in columns with spaces between each field. So that's what we have, a space between each of the columns. But some of the data is going to have what's called a delimiter. Okay, and let's take a look at some of the delimiters that you might have. So if I click on that and go to next, I see it could be a tab, it could be a semicolon, it could be a comma. These two are probably the most common. So if that's what's separating your data, you would be using this tab here, delimited. But because I've got the fixed width, I'm going to use this. Just press next a couple of times and finish. And there you go. Lo and behold, everything is split up into columns. All right. Now, the only columns I'm actually interested in are the first two. Okay. So the year is going to represent the X value on my graph. And this anomaly, which gives me is going to help give me the temperature, is going to be the Y value on my graph. Okay. So if I press the Control or Shift button here, and I take these two, I'm going to now create a scatter plot with this is the X, this is the Y. All right, so you're going to want to go to Insert, okay, and you're going to want to look for charts. Sometimes the scatter plot will be visible depending on which version of Excel you're using. So here I just go to this tab and I choose the scatter plot. And here we go. We have our graph. All right, and let's take a look at that. And the first thing I notice is, remember those high uncertainties in those earlier years? Well, this is what's happening. There's no real pattern. These seem to be a little all over the place. And not surprising that this data is not likely very accurate. So what I'm going to do is I'm probably going to go for when things start to even out a little. So it looks like at around 1830, 1840, the data seems to be getting better. So nothing stops you from only taking part of your data. So I'm only going to start my data at, say, let's pick 1840. So what you do is just go start at 1840 and go down and pick the rest of the data. Okay, and now I'm going to do the same thing. I'm going to insert a scatter plot, and now I've got data that looks a little more reasonable, something that I can work with. Okay, so now we're going to start the analysis of this data. So if I just take a look graphically, I see that clearly temperatures are increasing, but I also notice that there seems to be a bit of a curvature. It seems to be increasing more quickly in more recent years. Okay, so that's great. This is great to display what's going on, but we want to go further here. We actually want to make calculations and maybe make predictions of what's going to happen in the future. Okay, so this is where you're going to click on one of your data points, you're going to right click on your mouse, and we're going to add a trend line. All right, and we see here that the automatic trend that they put in, if you look to the right, is a linear one. Okay, so essentially this is just the line of best fit. Okay, which fits a lot of the data, but I notice that, hey, look at this more recent data. It seems to be increasing much more quickly than this line suggests. So you've got two options here. You can either, again, cut off the data to more recent times, which would be reasonable, okay, and use another line of best fit, and you'd probably get something which is much steeper. Okay, but if you do want to include all this data because there's a trend over time, okay, what you can use is, instead of a line of best fit, you're going to use a curve of best fit. All right, and you've got some options here. So most of these functions we haven't studied yet. So the ones that you're definitely going to avoid are moving average and logarithmic. I would just stay away from those altogether. The four that you would consider are exponential, linear, polynomial, and power. Okay, I'm actually going to suggest that you stick with either linear or polynomial. These are the ones you're familiar with. So here's our linear graph. But again, remember, we want to make predictions. So we need to find the equation of this graph. So if you go to the bottom here, it says display equation and chart. So you're going to click on that. We'll move that in a second. But the other thing I want you to display is this R squared value. Okay, so let's move this over and make it bigger. Okay, so what we have here, is just a linear equation. Y equals mx plus b. And with this R squared value is an indication of how good this line fits the data. And essentially, the closer you are to 1, the better it is. So 0.78 is actually not bad, but we can clearly see it doesn't fit the data at the end. Okay, so here we lost our panel, so you can just right click here and go to format trend line. So what I want to do is I want to look at some other options and see if this R squared number goes up. So let's pick polynomial, and you see here polynomial of order 2. Not surprisingly, for some reason on my version of Excel, it doesn't automatically change it. So I'm going to go out of here. If you use the school version of Excel, this will pop up. Okay, so here I'm going to go right click, format my trend line, and here I'm going to got my polynomial order 2, display equation, display R squared. And here I see a quadratic equation. And I notice that the R squared value is significantly higher than it was before. Okay, remember it was 0.78. Here it's 0.84, much, much better. All right, so we can see if we can do something better. What if we use order 3? What does that mean? Hey, that means it's got an x cubed. And I look here again, a significant increase in my R squared value. Let's go and put in an x to the 4th. we see here the increase in the r squared value is not much. Okay, it's pretty much the same as the x cubed. So it's not worth using such a complex function if the cubic one gives us almost the same accuracy. And if you look at the curve, it definitely fits the data much better, and it's definitely increasing quicker in these more recent years as we expect. So this is the equation we're going to use to determine calculations. All right. A couple of things before we go there. All right, is what does this number mean? Okay, and how can we maybe make this a little more accurate? So let's go to our sheet of paper here. And what does 7e negative 0.7 mean? Well, you probably know from science this idea of scientific notation. So what this represents is 7 times, okay, 10. So this is not exponent, but it represents this scientific notation, 7 times 10 to the negative 7. And what does that mean? It means that if I take my number 7, there's my decimal point, and I'm going to move it to the left 7 times. So I'm going to have 0.0000007. So it's like my decimal point here was moved over 7 times. All right, so this is a very small number. The problem with this number is that there's only one digit, and I might be losing a lot of accuracy. So the last thing I'm going to show you in this video is how to increase the number of digits if you're in that situation where you've got such a small decimal number. All right, so you're going to click on your equation, all right, and you're going to go to Format up at the top here, and you look at your trend line, and you're going to format your selection, and you go here. Now, on the school version of Excel, this is going to look a little different. In fact, it's going to be a little more obvious, but what you're going to look for is you're going to look for number. Okay, and now this gives you some things you can change. So my decimal places, okay, I'm actually going to go and make that much higher. So I'm actually going to put in 12. Okay, why 12? Well, remember here, I had to go already to the 7th decimal place just to get my first digit. Okay, so I'm going to put in 12. The other thing I'm going to do is I'm going to ask you to take out this comma for where we have thousands. Now, I'll talk about that in a second, why we do that. And what you have here is now a much more accurate equation. All right. So this is what we're now going to use to make predictions for the future. Okay, this equation here. Remember, X represents the time, so the year in time, and Y, in our case, remember, represents that number that you're going to add or subtract to 8.64. Okay, so you might look at this and say, wow, I don't want to have to put this thing into my calculator. How am I going to solve equations using this? Well, if you have something that's not linear, then I'm going to suggest you watch the second video where I'm going to show you how you don't have to use your calculator at all, but some computer apps to input your values and solve equations without having to do it manually. Okay, so just to recap what we've seen in this video. So step number 1 is find your data. If it's already in Excel format, you can go to the next step. If not, you're going to understand your data, copy and paste it into Excel, okay, and then take your X and Y values, plot them on a chart, and then once you have that, you're going to use your trend line, okay? And you can pick linear or polynomial. If you want to explore exponential and power, if you have all positive numbers, you can do that too. And then from there, you use your equation to calculate particular values that are of interest to you. So for example, if you want to know what the temperature is going to be in 2050, you can use this equation to find Y and then add it to 8.64 to get the new temperature. So again, if you want to see how you can calculate these things without having to do it manually, you can watch the second video. That's it for this one.